Good afternoon, everyone. We are going to go ahead and get our program started. Welcome to Careers in Data Science. My name is Roni Rufian. I'm one of the assistant directors, career counselor at the UCLA Career Center. I work directly with all of our STEM students. In particular, I do programming for our physical sciences division. I work with undocumented students as well, and all of our pre-med and pre-health. Thank you for being here today. Tim, I know your camera's off, but did you want to introduce yourself really quickly to everyone? So if they have any questions, they can also reach out to you.
Sure. Yeah. So hi everyone. Thanks for joining us here. My name is Tim Marr. I am one of the industry relations managers here at the UCLA Career Center. I work mostly with our public service industry. So those are organizations like in government, law, nonprofit. So any employers and organizations in those fields that are interested in recruiting Bruins.
Thank you so much, Tim. We have an amazing panel and student orgs here today to talk to you guys about their organization and getting involved in the field of data science. But I did want to take a few minutes to do a quick Career Center overview as we kind of go through everything that's happening today. Let me move forward. Sometimes the screen plays tricks on me. All right. Quickly, for those of you who are not familiar with the Career Center services, I guess I just wanted to go through some of our resources and then we'll move forward with having our student orgs talk about their organization. And we have two amazing panelists here, Justin and Jason, with us today, who are going to talk about their career path, about their career history and how they got into the field of data science within the organizations that they work for. So very quickly, we do offer 30-minute one-on-one sessions through Handshake. These are appointments that you can schedule. Unfortunately, they are a little bit challenging to get, but if you go onto Handshake and you click on appointments and you notice there's nothing available for the rest of the quarter, that's really not the case. We post appointments every Friday between 2 to 4 p.m. For only up to 2 weeks in advance. And students do cancel all the time, so appointments do reappear on that. So just kind of be consistent with those appointments. Keep checking and you'll get an appointment, be it myself or my colleague Christina, who's on with us today, my other colleague Sanaz, and so on. So, just keep checking with those. If you have quick questions or questions about resume, cover letter, how do I, talk to a faculty member about letters of rec, if you're thinking about PhD programs and things like that, feel free to do a drop-in session. Those are much easier to get. Those are 15-minute sessions virtually or in person, Tuesdays, Wednesdays, and Thursdays, from 10 to 12 and 1 to 3 p.m. We have tons of events and workshops on Handshake. My other event that's coming up that might be of interest to some of you all is Overall Careers in Physical Sciences. So that event is happening on October 30th. I am in the process of finding someone also within data science, within that field, to come and talk about their industry and so on as it pertains overall to their major as a physical science major. So that's happening, but tons of events, workshops, career fairs, and all of that is posted on Handshake. We do have employer information sessions, which align really well with our on-campus recruiting process, which is going on now. Data science, the recruiting cycle is now fall quarter. These companies or these positions tend to hire almost a year in advance when it comes to internships and full-time jobs. So if you have questions about the hiring process and on-campus recruiting, I'm here to answer those questions afterwards, or you can ask Tim as well, or just come into a drop-in and we can walk you through the hiring process. And then again, our website's really helpful, tons of helpful articles and so on there that can walk you through the whole career development process and so on. So take a look at our website as well. These are just some of the resources that we have online on Handshake for you all to use. Again, Handshake is great. VMock is a AI document that can help you critique your resume. You can bring your resume for drop-ins, run it through VMock. It's really helpful. For those of you who are still maybe not sure, like, you want to go into data science, but you want to learn more about yourself, Focus 2 is a really good resource for that as well. It's an assessment that you can take through Handshake. It gives you titles of occupations. It talks about your personality, your interests, so you can learn more about yourself through that database. So this is just a quick glance of some of our resources that's available. It's hidden in Handshake because it's free for you guys. A lot of these resources, obviously besides YouTube, the company charges for, but we have it embedded in Handshake. And as long as you have access to Handshake, you are able to use the resources free of charge. Okay, so quick overview of what we do at the Career Center. I do want to invite our student orgs at this point to take a few minutes and talk about their student orgs and how, you know, their student orgs are involved in this amazing and great industry and events that are coming up and so on. So I wanted to first turn it to Kevin. He's from the Stats Club at UCLA. So welcome, Kevin. I'm going to stop sharing because I know you wanted to share your screen and give you access. So go right
Yes,
ahead.
let me know if you guys can see my screen.
Mhm.
Hi, so I'm gonna make this quick, but this is UCLA Statistics Club. We are the official statistics club and data science club under the Statistics and Data Science Department. So for any of you who are statistics and data science majors, minors, or also data theory, that department that is helping organize those classes is the department that we are working with. So what is Stats Club? Why you should join? I would just say Stats Club creates this really safe and inclusive space and environment for students who are interested in statistics, data science, and all of the related industries. And we're able to do this through career development, through our workshops, social events, mentorship, and through Data Fest. So how can you be a part of Stats Club? Well, the good news is there's absolutely no recruitment process. You do not need any experience and there's no complications. Every single person on the Zoom call right now can be a part of Stats Club by following this 3-step process. So first, join our Slack and our email list. This is where you're going to be receiving all notifications on upcoming events, such as our general meetings, socials, and everything that's going to be coming up. Definitely follow us on our Instagram at statistics.ucla. This is similarly where we are going to be hearing announcements on upcoming events as well as recaps from some of our socials. And lastly, show up to our events. So as speaking of events, our first general meeting is actually tonight. 2 hours from now, it is in Haynes A2 from 6 to 7 p.m. We're going to be doing some introductions to our board. The board will be introducing the different parts of Stats Clubs, such as our mentorship program, our brand new internship program, Data Fest workshops, and more. And we're also going to be introducing the upcoming events that will be taking place this quarter. And just in general, all of our future general meetings will be held every other Wednesday. So Wednesday of week 2, week 4, week 6, week 8, and week 10. So Stats Club does host Data Fest 2025. Data Fest is the biggest data analytics hackathon on the West Coast. Usually we have around 400 participants. We have judges who are statistics faculty, alumni, and it's really just this really great celebration of data science. So if you want to actually help out and be a part of the planning committee for Data Fest, you guys can actually apply to be a part of the committee. There are 3 different committees: finance, media, and events. And so again, the application is due this Friday, and we're going to be sending out decisions by next Thursday. So yeah, Stats Club has a brand new internship program this year. So if you are someone who is looking to be a Stats Club intern, help a little bit around the leadership side of Stats Club and help plan some of the behind the scenes work that Stats Club puts into all of our events, I would definitely recommend applying to become an intern. We will be recruiting interns during the middle of fall quarter, so make sure you attend all of our meetings and follow our socials to receive updates on this process. And yeah, thank you so much for listening to this presentation. If you want to stay in touch, again, follow us at statistics.ucla. Check out our website for some of our photos for some upcoming events and announcements. And if you have any questions that you want to contact us about, then message us at statistics.ucla@gmail.com.
Thank you so much, Kevin, for that. Very informative. I'm excited to hear about Data Fest and so on. Next, I wanted to introduce Medina and Jane, who are here from UMSA. If you all would like to take a few minutes and talk about your student org, that would be great.
Hi, I'm Jane. I'm one of the co-presidents of UMSA.
Hi, I'm Medina. I'm the other co-president of UMSA.
Yeah, so UMSA is the Undergraduate Mathematics Students Association and is the official math club of UCLA. We hold lots of different events, including social, academic, and professional events. So we have professor talks where professors speak about their research. We also have career workshops and career events as well. And then we also have social events, like Bobo socials, math giving, things like that for you to meet other math majors. We're open to all majors, not just math. And so if you're interested in data science, it might be a club that you might be interested in.
Just gonna add a little bit more into what Jane said. So specifically our mentorship program, which right now we're accepting applications to be a mentee. So to be mentored, I'm gonna send that link in the chat. It's a very easy application. You can just read through the different mentor bios and rank them based off of your common interests, your majors, things like that. And they can give you advice with applying to grad school, help you choose your classes, make a degree plan, things like that, just overall academic and social support. And to be a member, to be an UMSA member, there's a $10 fee, which I'm gonna send, I'll send the membership form in the chat, so this will join you to our newsletter. And if you pay that $10 fee, then you have access to the mentorship program. You get a free UMSA t-shirt. There's access to a LinkedIn photo shoot for LinkedIn headshots, as well as a resume workshop. So it's definitely a great investment to make. I'll send the link for our mailing list, and I'll also send all of our socials. So go ahead and follow our Instagram, check out our website. It's a great club to get involved with. Just a great club to meet people and yeah, get more involved with the UCLA Math Department. Thank you so much.
I want to add one more thing. So we have a free membership and a paid membership. So if you sign up the form on the mailing list, that's a free membership. And you, like, all of our events are free. The paid membership is really if you want to be part of the mentorship program. In order to be part of the mentorship program, you have to pay $10. But if you just want to come to our event, that's completely free. If you want to hear about our event and opportunities by signing up on the mailing list, that is also completely free.
Thank you so much for being here today and talking about UMSA and all the great opportunities the students have as part of your organization. Perfect. So now we're going to transition into our moderated panel session. The way it's going to work tonight is I'm going to take about 45 minutes, ask some general questions. We do have Justin Williams and Jason Yang here with us this evening. So I wanted to go ahead and allow our panelists to introduce themselves. And I'll ask the questions, a quick moderated panel, and then at about 5:30, at about 5 o'clock, I'm going to open up the breakout rooms, and you guys will all have an opportunity to just kind of jump back and forth between each breakout room and ask Jason and Justin your questions, or if you have any questions in the main room, we'll be in the main room as well. All right. Justin, I see you first on my screen, so thank you again for being here. If you can go ahead and just do a brief self-introduction. Obviously your name, education, and major that you had in undergrad, a little bit about your work history, current employer, and what it is that you do today with the Dodgers.
Sounds great. Yeah, so my name is Justin Williams. I am currently a senior quantitative analyst with the Los Angeles Dodgers. I got my PhD from UCLA in biostatistics in 2020, where I first also got my master's in biostatistics, also at UCLA in grad school. And my undergraduate degree was mathematics. At the time when I was pursuing my undergrad, I was also pre-med, so I was debating whether I should go down the medical school path or not, and ended up going towards biostatistics, and then ultimately with the Dodgers. So some of my work history is primarily internships with medical device companies, some in San Francisco, like Genentech, or a medical device company called Alcon in Texas that makes things like contact lenses and intraocular lenses for vision. Yeah, the Dodgers are my current employer. It's a very exciting and nervous time for us as employees right now, watching them in the playoffs. But I've been with the team now for a little over 4 years, and my work focuses primarily on long-term modeling and player evaluation, usually for the draft, so which players we should take from college or high school, as well as a few on-field products. So that's a little bit about kind of my history.
Thank you so much, Justin. Jason, nice to meet you. Welcome. Thank you so much for being here. If you can go ahead and also do a brief introduction, tell us a little bit about your educational background, your current position would urgently today, that would be great.
Sure thing. My name is Jason. Graduated from Berkeley in 2015 with a chemical engineering degree. Um, and then started working, obviously. And then I first started as a technical support engineer for a tech company in the Bay Area. I graduated from Berkeley, as you can tell from the background. And after that, I pivoted into data science. So was looking as to what opportunities are out there, decided that data science was the best fit, went for it, took some boot camps at the time, and then made the transition. And now I've been in data science for 6 years now, as a data science manager now. And my current role as data science manager at Urgently, I work with my team to make real-time price and ranking predictions on roadside assistant jobs. So think if you're on the side of the road, you are looking for help, you work with your insurance might be using our software. And I work on the algorithm side in terms of determining who we should send to you and how much that job should cost. So lots of jobs, lots of data flying around every day. We try to do it. We do it in real time. So as the job comes through, we're updating and requesting and predicting how much things should cost and who should we contact. So that's a little bit of my work as a data science manager at Urgently.
Thank you so much. Jason, maybe I'll continue with you with the next question. The next question is, why did you choose your specific degree? I know you mentioned boot camps, and there's definitely, you know, when I work with data science students, we talk about, are there specific courses on the side they can take that could help them with programming and understanding different languages and so on. So can you kind of walk us through why you decided to pursue your degree and transition into data science? And off the top of your head, or any courses or languages or anything where you're like, this was super helpful in my career path. I'm excited that I was able to take, you know, R or whatever it is, or learning about this language that you would advise students, or specific data science, let's say course, not even courses, but programs that you would recommend for our students to take.
Yeah, so great question there. I picked my degree because, well, back in 2011, data science was like a very new field. And I didn't know about it. And I picked chemical engineering because I wanted to do chemical engineering work. But once I graduated, I started exploring what was out there and what roles are available. And I found data science to be a better match with my interests. In terms of once I figured that, I had to go find out what I needed to learn to get there, some of which mathematics are very important. Linear algebra is kind of like a cornerstone of like GPU. So NVIDIA runs on all of it is a linear algebraic calculations on a GPU side. Things are parallelized. So having strong foundations in mathematics will help. Linear algebra does help. So trying to make this digestible. So to be a data scientist, you should know mathematics and programming. Now, in terms of mathematics side, statistics is also key. So having a combination of statistics and linear algebra will be helpful. In terms of programming wise, R and Python are the two big languages. So it depends on which area you want to go into. If you are more decision science, running tests and control variant A/B testing, R is the better language. I think they have really good packages for that. And I think a lot of teams do run on R. But I would say like maybe like 60% or 70%, you can cross-check this with the job postings, like just look up data scientist jobs. You'll find that more teams use Python. I think it's a language that's used in production more because it interfaces with software engineering more. So Python is also very important. And then it is a spectrum. So if you go more into like data engineering or go into the machine learning side of things, you might even touch upon Spark. And there's the landscape is constantly changing. So I think the best way to really get a sense of it is to look at your ideal job, look up 5 of them, do your own data analysis of what are the common requirements that they post. And a lot of times, having strong mathematics will be helpful. Having experience in R and Python are generally a requirement. And then there might be additional asks of like knowing Spark or knowing certain cloud environments. So I would look at I would default to the current job market and find out what are the most recent requirements.
Thank you so much, Justin. Same question, please.
Yeah, maybe I'll start a little bit more on like the career path decision of grad school versus not, and like medical school versus ending up in like a more data science, biostatistics framework. I kind of knew like an undergrad that I enjoyed math problems and thinking critically about problem solving. And after majoring in math, I kind of realized I don't love proofs. There are certain parts of math that are super important to understand, things like convergence, the central limit theorem, how do things behave as we get a large number of samples that are extremely important for concepts in data science, as Jason was kind of touching upon. Having that background and being interested in health kind of led me to biostatistics at the graduate level. There's often people that come into our workforce with the Dodgers straight out of undergrad and usually come in at more of a junior level, but there's opportunities to advance from there pretty easily as well. But I think for me, going to graduate school and getting more in-depth statistical tools that I could use across a variety of different problems and different approaches was really helpful. So getting some exposure to machine learning, some exposure to Bayesian techniques, and when and where and how to implement those. The specifics of like the programming language you use will vary as well. For sure, the more production environment, the more cross collaboration you're trying to do with a systems team or data engineering will be more Python heavy. I think my advice for undergraduate students would be to focus on a single language and become more intricate with the details and the nuances of how that language works. And those concepts will generalize more easily rather than trying to learn 2 different languages simultaneously. So looking at job postings and seeing which ones are Python are more common in the jobs you're looking for is a good way to go as well. But yeah, ultimately, studying biostatistics, I found that those skills were then applicable to baseball problems, and I enjoyed baseball. So rather than working for a medical device or a pharmaceutical company, I ended up deciding to go with the Dodgers and solve similar problems, just in a different domain.
Thank you so much. Justin, just so that we can kind of continue the conversation, a follow-up to that, you both talked about the technical skills. Could we talk a little bit about the soft skills? So we always talk to students about, being able to talk about your ability to communicate, your ability to collaborate, your ability to, those amazing soft skills that everybody needs on their day-to-day. What do you notice as soft skills, or we'll call it transferable skills, that is mostly needed in what it is that you do today? And any advice for students to be able to really highlight those skills in their resumes? Because a lot of times when I work with students, they're like, well, I don't know where to exactly be able to highlight those. We talk about student orgs obviously as being one place, but what are some of those soft skills or transferable skills that your organization, what you do today, values?
Yeah, I think working in a data focused part within the Dodgers is kind of a unique area to kind of see what soft skills are important, because often we're developing things that we need to present to a very non-technical audience. So you can think of that as baseball scouts who have maybe some exposure to some basic statistics, but not much outside of that. So being able to describe concepts at different technical levels, I think, is often a separator in terms of soft skills for people. So thinking from like a resume, being able to describe who you gave presentations to and kind of the varying levels or degrees of explanations that you have to give. Obviously being able to work as part of a team, so in a collaborative environment. I'm thinking of like if you have a GitHub page, if you work on a project with a couple other different people, writing code for yourself is often very different than writing code with other people. And I think that's a skill that we would like to see from applicants, is you can contribute to a project that other people are also working on. So I think those are some of the main soft skills I would think of that we would look for.
Thank you. Jason?
Yeah, I plus one on what Justin just mentioned. I think maybe as like a guiding question of like what is a typical interview question that gauges soft skills, communication, working on different departments and people of varying technical backgrounds. A common question that I ask and one of my friends or mentors ask, she's from Google. So from big tech companies to even the small tech companies or generals and companies in general for data, the common question is, can you explain statistical significance to a party that doesn't without technical terms? And there's variations of that, like, hey, you just ran this analysis. You have some findings, but explain it to a non-technical audience. So that soft skill is like a very good gauge of soft skills. And if you're able to explain that well, then great. And then they might then ask you the technical side of like, what does the p-value mean? What if you can't get the p-value, then what do you do next, right? Then you then go into the technical side of things. But having been able to converse from a technical and non-technical perspective is a highly desirable trait. It shows that you can understand where the other party's coming from and get them on board or understand their growing pains and translate it into a technical problem that you solve or work with another team on. So plus one on what Justin mentioned.
Thank you so much. Just to give our students a better perspective of your day-to-day, I'm going to add a two-part to this. Can you walk us through and your day-to-day and what that looks like? And the big question has always been, with AI, what role does AI play into that day-to-day? Or you can even split that into two different questions of, but what role does AI play in your day-to-day now within the last couple of years? And we can start with Jason, if you like.
Data is a very hot topic right now. So I think it's varying degrees, and I think I think the most common types of AI is large language models as of right now. So like something like a chat GPT. And I think there's different applications of it. Are you building your own large language model, optimizing it? Or are you using like a service like ChatGPT and building something on top of that? Right. And I'll have to say, like, unless you're working with a language-based system, you're not using that day in, day out. So unless you're working as like at Grammarly or at a chat agent, it's a little harder to work on that directly. So in terms of like AI working on the day-to-day, I would say components of it bleed in, like some stuff like, um, designing a system that can be improved upon over time. So that's like feedback loops of improving AI systems or machine learning systems in general is always an evergreen concept that applies to more than just AI systems. It's all modeling systems require that. And so, in short, in terms of me working with AI day to day, I would say the basic principles I've worked with, but the actual like the hottest AI topics like ChatGPT, large language models, I mean, I work on pricing and ranking, so like I'm not using a language model to help with that just yet. There are something more rudimentary for that. Now, in terms of my actual day-to-day, I think most days is as a data science manager, I have a set of projects that I'm evaluating, and I need to identify which project has the most revenue impact and what are the potential technical requirements of it, and whether or not my team can deliver on those technical requirements. And if we can, then how much time do we need to build those models, run those analytics, And if we can't, what are the components that we're missing? Do we need support from other teams? So as a data science manager, I more or less oversee my team and what the requirements are, and I try to set them up for success in terms of what the business needs for data science in their products. That's it for me.
Thank you. Justin? Two-parter question in this.
Yeah. I'll start with the typical day-to-day and then touch on some of like how AI has been coming and creeping more into our workflow. Yeah, so typical day-to-day is I'm a full-time remote employee now with the Dodgers, and so I would open my laptop and I would have a set of issues that we'd be tracking, which describe components of work that we want to complete in order to do a project. For instance, we need to have some aging curve to be able to make projections for college players on how good they're going to be in the future. So I would have an issue related to that I'm tracking my work on. I'm writing code in order to test hypotheses, and reviewing code from my other teammates to see, so we can get other pairs of eyes on the work. And we're kind of systematically going through and closing issues that relate to larger epics, that relate to goals of projects that we have going on throughout the season. Our work is often follows closely the baseball calendar. So I work primarily on amateur related projects. So when the draft is coming up, my work is picking up very heavily. And then when the off season comes, we're making decisions about what players to sign. And so we might have a boost in work need as well. So it varies some depending on the calendar. But most of all of it's like programming, making presentations, tracking issues and progress along those lines. In terms of how AI has been integrated more into our work, I agree that, as Jason said, like unless you're with a company that is building from scratch a large language model, you'll most likely be hitting a service that uses another company's model. And I think for me, the biggest tool that's been helpful is AI pair programming tools. I think these are becoming much more commonplace, especially as they have models now that can be used within your current work environment to have security so that you're not sharing all your code to, for instance, GitHub Copilot, which if you use GitHub Copilot, they have access to all your code, which can be a downside when you're working on proprietary projects. But AI pair programmers are things that you can use to interactively ask questions and prompts within your own code. So it can do things like look at this data set I have created, make a plot of this XY variable, and write the Python code for me. So in that way, it's, I think, accelerating some of the work that is often boring about programming, like writing documentation, writing unit test, remembering is pandas, how do I rotate this object, or what's the command in Plotly for making this figure? I found that to be by far our biggest group, our boost of AI within our organization is pair programming.
Thank you so much. Jason, if we can just continue with you. My next question is, what do you find most challenging and what do you find most rewarding in your day-to-day and what you do?
I think the most challenging aspect is sometimes like I think the most challenging is also the most rewarding. Thank goodness that the challenging is the amount of challenge, the amount of effort matches the reward. So I think the most challenging is that in a business environment, the problems don't arrive in a data science format. Like, for example, like, oh, we want to improve customer happiness. Like, by what metrics and with what product? And how are you measuring this? And is there a test setup for this? And how are you going to set up the test? Right? Well, are you going to ask them, are they happy? Right? Like, will they be honest when they ask when you ask that question? So I think a lot of business questions is very challenging because the business has something like we want to hit a revenue goal or we want to make sure our customers come back and sign with us. And that is what drives the business. That's what drives their profit. But when it arrives to me, I need to translate that into a technical problem that we're going to solve. if we're trying to improve user happiness with our product, I need to find out which part of the product we're going to implement that. And I think sometimes it's really challenging to figure out how you translate a business problem into a technical one. In terms of rewarding wise, I think sometimes you find an obvious solution like, oh, we realized that a button was just not usable, or we found a data point that points to something breaking down in the customer journey. And it turns out that a button that we released was never clickable. And then you just made that clickable and boom, you're very successful. And then you can do A/B tests like, what if we change the color of the button? What if we made the button, what if we made a second button or something like that? And so some of those is, the rewarding aspect of it is finding those signals in the data and then tying it back to a business problem and realizing that, oh, you have like 1,000 signals here, but we really need to focus on these three. And if we can just improve on these three through these actions, and you do it, and then you realize that, oh, it's actually driving revenue up. It's driving user engagement. And you can see that, and you can actually change parts of the business by just taking action on certain data points. That's a very rewarding part. So just to recap, the the problems don't arrive in the data science format. Oftentimes, the most difficult ones are the most rewarding when you're able to connect what a business requirement is to a technical requirement, and then you make that change, and it actually makes the impact that you expect, or even more. So that's to me sometimes the most rewarding parts of working in data science.
Thank you, Justin.
Yeah, I'd say the most challenging in my current role is trying to balance new projects as well as like maintaining and keeping current production projects running. So there's often like a technical debt of products that are currently being used that users may flag errors or problems or features they want to request on a current product. And you often have a new project that you're really excited to work on, and you have this modeling idea that you want to get to. And often you don't have time to solely focus on that because you have other requirements as part of your job that you have to make sure that things that are important to the organization are still working, and you can build on that. So managing the technical debt and the trade-off of just like time availability and prioritization of projects is challenging. Some of that's not my job. Some of that's our director will tell us what projects we need to work on, but it's always kind of a balancing act, and being able to context switch is an important part of making that successful. I think the most rewarding part of my job is that the models I build are used directly by the Dodgers. So when you see players moving on the field, this is because of a model that we've built that tells them where the outs are most likely to occur given fielder position, given who's pitching, who's batting. When we go to select players in the draft, like I'm at the table with our decision makers and we're using our models that we build. And so you feel like you have a lot of skin in the game in terms of the products that we build are directly used by our decision makers. And so that makes the work like extremely rewarding for sure.
Thank you. Justin, maybe we'll just continue with you. Within the field of just data science in general and tech, there's constant changes. So my next question is, what changes do you foresee continuing in your position and what it is that you do in the near future or in the long term?
Yeah, I definitely think that there are changes that are happening rapidly with some of these AI tools that are being built around like our infrastructure with how we work. I mentioned like the AI pair programming. It's making programming easier across a broad range of positions within our organization. And I think that the other big change is like the types of problems that we're going to be asked to solve are changing constantly. The data that's available, especially within baseball, you can think of at the beginning, there was like box score stats, like how many hits did you have a game, how many stolen base, how many errors. And with each, I don't know, let's say like 10 years or so, we've gotten like pitch tracking data. And now we have bat, ball, and play tracking data. And the next frontier feels like we have this biomechanical data of how our players moving through space and time. And this data is captured much more granularly and across a specific subset of games. And so there's a unique set of challenges in terms of how do we model this? How do we measure interventions that we want to apply for different players? How can we tell if they're successful or not? So I think both the scale, the type of data, and the ability to apply interventions is going to be a new frontier for how we think about baseball analytics, for instance. Yeah, I think there's some of the cutting edge, we could say, for those sports.
Thank you. Jason?
So I'll answer the question what I think is most exciting, because I think I've watched the ecosystem kind of develop over 6 years, and maybe even like 8 or 10, depending on the reach of it. And I think like it's really interesting how the data field has changed. And I think nowadays you probably heard that there are companies who say that we are an AI company, right? I think that term is much more prevalent today. I think maybe 4 years ago it was like we are a data company. And then maybe 6 years ago it was like we are software or SaaS or platform, right? So I think what's interesting, my interpretation of that is in the beginning, it's about building software experiences. And then at some point, people realize that you need to, if you have really good data, you can build a software experience around that. So data is kind of like the central part of it. And then this is where you have different models that can be performant depending on compute costs. So you have something like a logistic regression versus a XGBoost versus a deep learning neural nets or something. So you have different types of models chewing through the same set of data, showing different performances. And what's really interesting about the current day over the last 2 years is instead of like algorithm is like you have models that's pre-built or pre-trained. So these are your large language models, so or general models that then you then fit to your data, right? So the ecosystem has shifted from just like software to data to model algorithms to pre-trained model and algorithms that you then train on your existing data. So I think that trend is only going to continue forward. So I think it's no longer good enough to be a software company. It's no longer good enough to just have the data. I think it's exciting in that the newest models are all pre-trained, or the most performant ones are often pre-trained on large models and then pruned down. So that's has even the playing field a little bit. But I think that's the trend in that like you got to have the data. You got to know the algorithms, and you got to know how to then combine the two to be at the edge in the forefront. So in my view of like how things are progressing and how AI or how systems have changed over time and what might be useful later is being at the forefront and being on edge, because I think the trend is that you are going to be much more AI focused. You are going to need that data. Just having software technical skills is not enough to make it in a business these days.
Thank you so much. Jason, we'll have you continue with the next question, if that's okay. You mentioned about just being in this field over the last 6 to 8 years and changes and so on. So kind of thinking back or taking you back to when you were an undergrad at Berkeley and so on. What is it that you wish you would have known back then as an undergrad student before entering your career? Is there something or piece of advice that you would have wished you had back then to kind of make this transition? I don't want to say smoother, but what is it that you wish you would have known, or piece of advice that you can give our students today?
Yeah, I think the thing that I would tell myself back then, if I have a younger version today and I tell him, I think it's easy to feel very underqualified when looking at these positions, and because every position is kind of unique. And when telling myself, when you feel like you're excelling at one and you look at the next role that you're applying to, you can often feel very underqualified. And I feel like that's okay as an undergrad. That's okay when coming straight out of college, because employers aren't grading you based off of what you've already done. They're really grading on what your potential is. So there might be like, I don't know, 10 requirements on that resume. It's okay if you only touch like 3 of them. I have really good experience and maybe touch 1 or 2 additional on there. But what the employer is really looking for is growth and potential. So until you get that first job, as you're applying to that first job, like focus on the extracurriculars. Before we even started, there were like 2 good clubs, student groups that are available. Join those. Try out the new languages. Try a hackathon. Go into comments, try to build something. You know, and that adds on to your potential. That adds on to your experience. And so the advice that I would give to my younger self is like, don't be so harsh on yourself. Um, just try things and know that with any entry level job, you're going to be under-equipped in one dimension or another. And know that the employer is really looking for growth and potential because they know that every undergrad is going to not have a lot of work experience. And know that all the requirements is more like wish lists. And then know that those requirements are more harder requirements when you're 5 years into your career. Then you should at least have touched that language, have had 2 years of experience doing something. So my advice is focus on potential, focus on what you can deliver on, and try all the languages, try all the problem sets, try all the different things you can build on your free time, and then take your best shot at the job, and then apply often.
Thank you so much. Before I move to Justin, Jason, just another follow-up. I know we didn't talk about networking and building your network and so on. I thought it'd be important to kind of throw that in there as well as we round up the panel. Can you discuss a little bit about your experience in utilizing like LinkedIn or building a network for yourself when you were an undergrad, and any advice that you might have regarding that process when it comes to your career path?
Yeah, networking is very tricky. I remember when I was a freshman at Berkeley, I went to networking sessions and I was like the only freshman there and it was hard. And the first few times are always going to be awkward and difficult, and you just rely on your upperclassmen to kind of mimic them or like learn from them. And it's always going to be weird trying to talk to the same person when other 10 students, and it's hard to stand out. But just go often enough and eventually you'll know what are the good questions, or what's different about this company compared to the other companies. I think it's like all things, you want to practice, 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 and eventually you get somewhere. And so in terms of LinkedIn wise, like I think after the panel, if you go to a panel, a virtual one or in person, or a in-person networking event or a career fair event, take the business cards, note who's on the panel. I actually sent Justin Williams a LinkedIn request. You should be sending us LinkedIn requests as these are happening. Not because you need them today. It's because when you graduate in 2 years, or in 1 year, you can be like, hey, I remember you from this panel. I graduated now. I just want to let you know that I was a fan of your business. I might, if you're a fan of Dodger, say, hey, I did my own analysis with Dodger data. Can you just review it and let me know if I did a good job or if it's something? And don't even ask for the job. Just say, hey, I'm such a big fan of Dodgers. I did this on the side. Can we have a coffee chat? Justin would, I assume, very happy to just review your data set, and he'll be like, oh yeah, that's really interesting. And if you have something that he didn't know about, you're hired because or he'll tell you that, oh, by the way, we have these proprietary data sets, or there's this other GitHub repo that you should look at, right? So I think that's really the basis of networking. I think it's very intimidating at first, but just do it on the side in the beginning, and then later on, when you actually need to reach out to someone or you have something to say, then contact them. And so it's daunting in the very beginning, but I think it helps in the long term just to be staying connected and just making a little effort here and there, and then it'll add up.
Thank you so much. All right, Justin, final question. What do you wish you would have known before entering your particular career path when you were an undergrad? Any final advice? And then again, I kind of threw in that networking part. just to kind of discuss your experience as far as when it comes to networking and your career path over the years.
Yeah, I think looking back on kind of my path, I would agree that like signing up for different extracurricular clubs, getting to work on projects with other people. There's so many projects now that are in competitions that are available online. You can think of Kaggle competitions. You can think of there's a really fun one we actually do with like Dodgers every year. It's like Advent of Code. There's like 25 different coding problems that come out. You can do them in any language. Like that's been a really fun way for us as a team to get to work on different problems. And like Jason mentioned, like when you go to apply for a job, someone might list AWS cloud services. Like we don't expect undergraduates or even people that come from academia really to have exposure to cloud services, but reading blogs of people about how do I keep a production model trained and how do I make predictions in real live time? Like what are some of the challenges? Being aware of some of these concepts and just like start thinking about the entire ecosystem of modeling and about prediction and about how do I train models? How do I test models? I think things that I've learned throughout my career have been like the importance of selecting a good evaluation metric, of making sure that you properly define your outcome, being able to create trained test splits. Often in grad school or in school in general, we are given a data set and we say, try this model out. It's often the model that's chosen a priori to work pretty well. But you can even take that same data set and try a different model that you've always been curious about. And demonstrating different ways about how you learn. Do you read documentations of different packages? Is it, again, blogs? Do you find a GitHub page that's super interesting? There's so many resources and tools out there that I think being interested in learning is a really big signal, and something that I think will help you throughout your career, because you always be facing different problems throughout your career. And in terms of like networking and kind of some things that I've found to be successful is when you meet someone in person or in virtual, if you're attending the same event, reaching out on LinkedIn is a great way to stay in contact with someone. And then should, for instance, you want to transition or you're like curious about what's going on with someone else's career, reaching out, setting a time limit, often be like, I just want 15 minutes of your time and we can catch up with coffee or whatever. And I want to talk about A, B, and C, and kind of respecting people's time. Or if you, I think Jason's suggestion was like, if you come up with interesting problem that you want to work on, and just like send that as kind of I've been working on this and thinking about this concept. Like, I would just appreciate any advice that you have. That's a useful way to kind of start a conversation. And it doesn't have to be like constant with everyone in your network. Like, I don't reach out to most of the people on LinkedIn very regularly that you're connected with, but having people there in different industries, and people that you've had conversations with over a longer period of time, I think make the connections easier to pick back up. So I think those are some of the things I would suggest to students.
Thank you so much. At this point, we're going to start transitioning into our breakout room. So I wanted to thank Justin and Jason for being here this evening. Thank you for sharing your experiences with our students. Thank you to our student orgs for being here. We really appreciate all your time. I know a lot of students are excited to just meet with you individually in the breakout room. So at this point, we're going to end the moderated panel session, and thank you again for being here tonight.